Today we'll start with a new topic, complex numbers. So complex numbers, why were these numbers introduced? Means when we studied from natural numbers to whole numbers, means natural numbers were the first numbers that we studied, 1, 2, 3, 4, 5, 6 and up to infinity. Then we studied whole numbers, 0, 1, 2, 3, 4 and all those things. After that, integers were introduced, like negatives of the natural numbers. What was the intention behind introduction of integers? The purpose to introduce the concept of negative integers was that so subtraction operation was not completely defined on the set of natural numbers. For example, if you want to solve the equation, let's say I give you 10 minus 3, 10 apples. Out of them, I took away 3 apples. So this answer you can find out. Yes, 10 minus 3 is equals to 7. But if I tell you, so what will be from 5 apples if I took away 12 apples? Then this question was not solvable, or you can say that's x plus, let's say x plus 5 is equals to 3. No solution in the set of natural numbers. And to expand our concept of natural numbers, we introduced a new symbol. What was the new symbol? That's the answer was 2 and assert a negative sign over it, and this new symbol we introduced. Like that, a number system we expanded. We could have stopped at that point, that x plus 5 equal to 3 is not solvable, or instead of restricting our world of numbers, we can expand it with a new definition like negative 2. And then we defined some rules over the set of integers. The negative numbers that we defined, -1, -2, -3 and so on, we defined some new rules, new properties over those numbers, integers, and we expanded a number system. At that point,
good evening, sir.
Good evening. Okay, so integers were formed, and now once integers were formed, like say minus infinity to up to -3, -2, -1, 0, 1, 2, 3, 4, so on up to infinity. Now multiplication operation was giving a problem for division operation. If you took any two integers of your choice, let's say -2 and 10, and if you apply the multiplication operation, definitely you will get your whatever numbers are known to you, you will get the answer. But if you took any two integers of your choice and you apply, and if you perform the division operation, let's say -48 and 12, if you apply the division operation, sometimes you may get the answer. Okay, here we are lucky that we got the answer, but it's not always possible to get the answer. Let's say -50 divided by 12. Now the numbers that we know, those numbers, this answer is not possible. So we gave a new definition. What definition we gave? All the integers divided by all the integers. Take all the numbers of these form. I'm not writing the complete definition. Or take all possible combinations, form a set, and that set will call the set of rational numbers. We represent it by the symbol Q. So again, when we got stuck over an equation, instead of saying that this equation is not solvable, let's say x divided by 5 is equals to 5x. 5x is
Your voice is
5
breaking.
multiplied by x is equals to.
Sir, your voice is breaking a lot, sir.
Yes, sir.
Okay.
Yes, sir, it is break.
Please wait. Okay, so instead of again stopping at this point, that there is no solution to this equation, we expanded a number system. At that point, a number system was only integers, so we expanded a number system to encompass. You can say we invented more numbers. The more numbers that we invented was the set of rational numbers. After that, there were some irrational numbers that you know. And all these numbers up till now, natural, whole, integers, rational and irrational, all these together were called as real numbers. Natural, whole, integers, rational and irrational. Now irrational is also represented by q complement. All of them together were called as real numbers. This much you already know. Now still there was a problem. Like see, to what were the two initially, so that x plus 5 equal to 3. To solve this equation, we solved minus 2, 5x equal to 2. We invented the, in order to solve this equation, we invented the new numbers called as rational numbers. Still now, to solve this kind of question, like say x square plus 4 is equal to 0. Now the numbers that we know up till now, the real numbers, this equation is not solvable in the set of real numbers, because x square is equals to minus 4. There is no such real number whose square can be negative 4. If you are thinking some minus 2 is the answer, think again. Some minus 2, its complete square is equals to 4 and not minus 4. Okay, so this equation is not solvable in the set of real numbers. So again the same choice, now again the same two ways exist in front of us. Either stop at this point, that no sir, it means this number is not possible only, or you can expand your existing number system. You can invent some more numbers. Whatever the more numbers you will invent, you will have to define the properties also for those new numbers. So in order to solve this question, in order to solve this equation, the new numbers were defined, and the new numbers that were defined were called as imaginary numbers or complex numbers. Okay. Now you may think that if the name itself is imaginary, so these numbers as such, they do not exist. They are just for the solving purpose only. They do not have any significance. So to remove that feeling from you, can you answer this question? That's a minus 2. Minus 2 we have been studying from, let's say, 7th standard, 6th standard, 7th standard. We have been studying numbers like minus 2, minus 3, minus 4 and so on. Can you tell me how minus 2 apples will look like? If I tell you to show me 3 apples, you will take 3 apples in your hand and show me. If you take 10, if I tell you to show me 10 apples, you will take 10 apples in your hand and show me that these are 10 apples. But can you show me minus 2 apples? It's not possible. Can you show me minus 3 apples? It's not possible. So as such, if you think closely, minus 2, minus 3, minus 4 also, they are also meaningless. How can you show me minus 2 apples? But still we are so much comfortable with those numbers that we never got the notion that they may be meaningless. And to at the starting point, means at the beginning of these numbers, you may think that the people at that time, they may have thought that these numbers are meaningless. But today we deal with the credit system and debit system. You have earned 10 rupees and you earned minus 10 rupees. Means what? You earned a profit of 10 rupees and you incurred a loss of 10 rupees. Your bank account debited with 10, debited with minus 10. You get the feeling that negative numbers we use a lot in the banking system today. Okay, so minus 2 apples meaningless, but those numbers find application in suitable places. So similarly, imaginary numbers also, don't think they are just imaginary, they find applications. Okay, so now to define negative imaginary numbers, or you may also call them complex numbers. Minus 1 under root was defined to be equal to I. Minus 1 under root. Now in the set of real numbers, we definitely know that whatever this under root is, some number x square plus 1 equal to 0. So x square is equal to negative 1. The number which satisfies this equation the number which satisfies this equation was defined as, was given the symbol I. I for iota. Okay, iota, that I. And so I square, I was such a number whose I square is equal to -1. This is the definition. We cannot, neither you nor me can question this of why I square is equal to -1, because we are expanding a concept. Okay, so by that point only I was actually the square root of -1. These two things are the definition. Now, once you have this I equal to a -1 under root, another point that we remark that I want to tell you is, many students have the doubt, that's a C. You told me that I is equals to under root of -1. So I multiplied by I will be what, sir? -1 under root multiplied by -1 under root. So this will be equals to common under root -1 into -1. So that will be equal to under root and 1. And what is, sir, under root 1? Under root 1 is equals to 1. And this is I square. So I square should turn out to be equal to 1. So what is the mistake, sir? I square should be 1. The mistake is at this stage. -1 under root and -1 under root here. This equality is incorrect. So just write this remark and I will tell you the laws of why this equality is incorrect. So don't go that I square will be equal to 1. I square equal to -1 is the definition. No question in that. So now if I square is defined to be equal to -1, now can you tell me some powers related to I? So I raised to 1 will be equal to I. What will be I square? Sir, I square to हमको पता ही है. We already know I square is equals to -1 by definition. What will be I cube? Sir, I cube, can I call this to be equal to I square multiplied by I? I square is -1 and this I as it is. So I cube is equals to -I. And so what is I raised to 4? So I raised to 4 is I square multiplied by I square. So what is I square into I square?
1, sir.
-1 into -1. So the final answer is 1. So all the 4 powers I will write again. I raised to 1 is I square is -1, I raised to cube is -I, and I raised to 4 is 1. After this, the power goes on repeated. The power repeats itself in the cycle of 4. I raised to 5, I raised to 6, I raised to 7, I raised to 8. What will be I raised to 5? So nothing you have to do, just I raised to 4 multiplied by I. Since I raised to 4 is 1 only, neglect this. I raised to 4 is 1. What remains is, sir, I only. I raised to 6. I raised to 6 is what, sir? I raised to 6 is I raised to 4 into I square.
-1.
Yes, I square. So this will be -1. This will be I cube, which is equal to -I. I raised to 8 is same as I raised to 4, which will be again 1. Clear? I raised to 9, after that what, sir? I raised to 9 is again I raised to 8 multiplied by I. I raised to 8, just neglect this because it is 1. So again the cycle will be repeated. So can you see that the powers of I repeats itself in cycles of 4? So if you understand this point, now answer this question. I raised to 34 is equals to question mark. second I raised to hmm. Shall I give the answers? Have you solved it?
Just a second.
All the answers will be of this form only. Either I, negative 1, negative I, or 1, or maybe some simple integer, something like that.
First answer is -1.
Yes, first answer is -1. So I raised to 32 I will do, and I square. 34 is I raised to 32 multiplied by I square. Why I raised to 32? Because I know that I raised to 32, I can cancel out to be equal to 1. And I square is -1 by definition. So the final answer is -1. I raised to 4, any power of 4.
Sir, second answer is also -1.
No, second answer is not -1. I raised to 62. I raised to 62. Can I write this to be equal to I square, first number? And the second, can I write I raised to 64 is I raised to 4. Everybody get this? So why is I raised to 62 equal to I
Yes, sir.
square? The 62 is actually what? 60 plus 2, and the 64 is 60 addition 4. So I raised to 60 is 1, and I square as it is I raised to 60. 60 is a multiple of 4. It's 1, and 4 remain as it is. So this is -1, and this is 1. So the final answer is 0. Here 89 is what's the closest number which is multiple of 4. Closest number multiple of 4 is 88. So I raised to 88 multiplied by I raised to 1. Addition I raised to 88 multiplied by I cube. So what will be this? I raised to 1 is I only, sir. addition. I cube is what? I square multiplied by I, so that is minus of I. So it is again 0. I raised to 109. I raised to 109 is 108 plus 1. This is 108 plus 1. So 108 is a multiple of 4. This is I to the power 1 plus I to the power 2 plus I to the power 3. 108 plus 3 is 111. 112 is 108 plus 2. So this is what? I square is minus 1. I cube is negative of I. And this is plus 1. Fourth is also 0. Yes or no? Clear, everyone?
Yes, sir.
No. Solve this question. Concept is same, but there is a very high chance that you will commit a silly mistake. Just write done in the chat box when your answer is ready. For fifth one. Sixth one we'll discuss afterwards. When you've completed solving the fifth one, just write done in the chat box. Come on, students. Okay, shall I tell you the answer?
Yes, sir.
See, I raised to 39, I raised to 39, 40, 41, 42, 43, 44, and so on. The cycle is going on. If you just concentrate on the first four terms, let's say I raised to 39, I to the power 40, I to the power 41, I to the power 42. Just these four group, a group of these four terms. Then forget the rest terms. I raised to 39, can I write this to be equals to I cube? Why I cube? 36 plus 3. 36 will give me I raised to 36 will give me 1. 36 plus 3. I 30 plus 3 will remain. Yes or no? I raised to 40. I raised to 40. I can write it as to be equal to I raised to 4. 36 plus 4. Yes or no?
Yes, sir.
41. 41. Can I write this to be equal to I to the power 1? And 42. 42 can I write to be I square?
I to power 2. Yes.
Okay. So any four consecutive terms after this again the 4 table will be repeated. So 4 means I raised to 3, I raised to 4, I raised to means when the next term will be sir I to the power 43, I to the power 43. So I will again write it to be equal to I cube only. 40 plus 3. And the cycle will continue. And you see this thing. So the consecutive four terms are I cube, I raised to 4, I raised to 1, I square. And these four terms addition is 0. The addition of these four terms is 0. Then the next the next group of four terms, that addition will turn out to be 0. Then the next group addition will be 0. Then the next group addition will be 0. So if you understand up to this point, you may have a feeling that so the overall answer, the final answer will be 0. That will be the case if I give you the number of terms very nicely. Means if I give you 39, 40, 41, means I give you the total number of terms in such a way that they all form a proper group of 4 terms. If I give you, let's say, total number of terms, if I give you 7, the first 4 will form a group and the last 3 will remain will not form a group. They will remain independent. So the last 3 together, their addition won't be 0. Okay, or if I give you, let's say, 9 terms, the first 8 terms will form a group of 4 and 4, so together 0, and the 9th term will remain alone. So the final answer will be the 9th term. So you just have to make sure that whether in the question sir has given us a proper group of 4 terms properly. So how to check that? In order to check that, 39, 40, 41, 42, this is my first group. Then 43, 44, 45, 46, this is my second group. 47, 48, 49, 50, this is my third group. In the last class in 10th standard, you have studied Euclid's division lemma. You see that always when number divided by 4, always the remainder is either 0, 1, 2 or 3. So you may think or one way you can see that, sir, okay, in
Sir,
all
that count was deleted, sir, last year. It wasn't there for us.
okay, no worries. See, you have to form a group of four terms, so you can see that, sir, whatever is the multiple of 4, 40, 44, 48, 49, 52, 56, 60. This multiple of 4 is operating at the second position. So here at the last, which is a multiple of 4, the multiple of 4 is this 160. So if in which group this I raised to 160 will lie? So I raised to 160, if at all it would have formed a group, that 160 should occur at the second position. It should it should lie in the second position, means I raised to 159, I raised to 160, I raised to 161, I raised to 162. This will be my last group, and the previous group, just second last group will end at 158. So up till here the addition is equals to 0, 0, addition 0, addition 0. What remains is I raised to 161 and I raised to 162 you have not given only. Those are the absent terms. So the only terms that will survive is I raised to 159 is left alone, I raised to 160 is left alone. So that will be my final answer. My final answer is I raised to I to the power 159 addition I to the power 160. But sir, I will simplify it. I raised to 159, I will write it to be equal to I cube 156 plus 3, and I raised to 160, I will write it to be equal to I4 156 plus 4, that equal to 1 only. This is equal to 1 and I cube is equals to negative I. So my final answer of this addition is equals to 1 minus I. This is my answer. Okay, don't be tempted to write the answer as 0. Is it okay, everyone?
Yes, sir.
The next question is also similar lines. I will not explain it completely. 26, 27, 28, 29. The first 4 terms, I raised to 26, I raised to 27, 28 and 29. Their addition will become 0. Then the next 4 addition equal to 0. Check whether the addition is becoming 0 in terms of in the group of 4. But here the number of terms that I have given you, all of them will not form a group of 4. So some terms will remain lonely. They will be single. So those terms that remain single and they do not occur in a group of 4, you will have to take those surviving terms and find the final answer. The final answer of this question is minus 1 plus 1 upon negative I. This is the answer, but I will make it little bit good looking. So how to make it good looking? So this 1 upon negative I which is there, can I multiply it by, sir, I upon I? It won't make any difference. If I multiply it by I upon I, so this negative 1 to as it is, addition, this numerator I as it is, and in the denominator minus I multiplied by I. Minus I multiplied by I is what, sir? Minus of I square. Minus of I square means this is minus I square. So I square itself is negative 1. So minus of negative 1. Can I write, delete the denominator? Minus of negative 1 is 1 only. So the answer is minus 1 plus I. You yourself verify up to this point. Okay, I am giving the final answer. Minus 1 plus 1 upon minus I. I am giving you this answer. I have not explained you. You can verify it afterwards. Yeah. Convert it into minus 1 plus I. This step I have explained. Have you understood the conversion?
Yes, sir.
So this question for homework, just verify it. Now, moving ahead, some definition in while solving equations. I have told you some remarks. We all know that 3 square is equals to 9 and minus 3 complete square is also equal to 9. Nothing new in it. But when I tell you to tell me what is this symbol, this symbol is specifically reserved for the positive value only, 3. We never say 9 under root. 9 under root, if you tell 9 under root is equals to minus 3, this is completely wrong, because that symbol is reserved for the positive value only. If at all you are determined that no sir, I have to somehow write that negative 3 in terms of under root value only, so then you can write some negative 3 is equals to, sir, 3 which is under root 9. 3 is the under root of 9 and minus of this complete value. Okay, yes, now this is correct. This was the meaning of that under root symbol. So in complex numbers also similar definition is there. Okay. Minus 1 under root is equals to, or let's say,
Sir, if it is a minus 9 root,
yes, that only I'm telling you, I'm coming to that point only. I square is equals to -1. This you know. This is by definition. So what is minus I whole square? You can verify that so minus I whole square will be minus I multiplied by minus I, which in turns out to be equal to minus according to minus. It turns out to
I
be I square only, and I square only it is -1. So I square is also -1 and negative I whole square is also -1. Correct? But -1 under root is said to be equal to I only. This is correct. Do not say that -1 under root is equal to negative I. This will be wrong. That is the definition of that symbol, under root symbol, how we use it. Okay, this clear? And now if you have, let's say, so what about -9 its under root? -9 its under root, if you want to say, -9 its under root will be strictly for 3 times I only. This is perfectly correct. But -9 under root symbol if you use and you're writing some minus of 3i, this is definitely 100% wrong. Although the reverse is true. Although the reverse is true. -3i whole square, if you will say -3i whole square, what will be equal to -3i multiplied by -3i. So that will be equals to 9 times I square. So that will be equals to -9. This is correct. But symbolically, if you are using under root, don't write under root of -9 equal to -3. That is reserved for the positive value only. Is this remark clear?
Yes, sir.
Okay. So after this, now under root A multiplied by under root B is equal to A multiplied by B under root. Up till now we have been means very broadly using this property, under root A into under root B equal to under root of AB. This is true if and only if at least one of A or B or both is non-negative. That both word लिखने की वैसे कोई जरूरत नहीं है, means it's not necessary to write the both word. When I'm writing if at least one of A or B, that is sufficient. Okay, but still for completion, means just for the sentence completion I've written, if both are non-negative, it's well and good, but at least one of them is non-negative, then only this property is true. Means when does this property get spoiled? If both of them are negative. For example, let's say under root 4 into under root 9, is it equals to 4 multiplied by 9 under root? You can verify that yes sir, this is correct, because you can directly see that yes, under root 4 is 2, under root 9 is 3, and this is 36. 36 under root is equals to 6. So yes sir, this multiplication is verified. This is correct. Both positives, it is verified. One is positive and one is negative. Let's say -4 under root, one is negative and one is positive. Can I write this equals to minus 4 multiplied by 9? It's under root. Let's check verification. The first under root is a 2i. What is the second under root? The second under root is 3i. And what is this? A minus 36 under root. Minus 36 under root is 6i. So can you see that's a 2i multiplied by 3 is equals to 6i? Yes, sir. This is also verified. So one negative and one positive, that will also do. But so now I can, the third case is same, 4 multiplied by negative and nothing different in this. 4 into negative 9. This is negative 36 under root, same. Third and second and third are same only. Now fourth is the problematic one. If I tell you, sir, negative 4, both are negative. Negative 4, negative 9. So you may say that, sir, this should be equal to, whether this is equal to, question mark, whether this is equal to minus 4 multiplied by minus 9, it's under root. What is minus 4 under root? So minus 4 under root is 2 times I. This is 3 times I. So the answer, the LHS answer is 6 times I square, which is minus 6. But what is the answer on the RHS? So the answer on the RHS is 36 under root. Both are negative, so the product becomes positive. And 36 under root, we never take it as negative 6, we take it as positive 6 only. So they are unequal. So this property fails. Okay. So you say A under root B equal to under root AB if not both of them, you can write off if at least one or both should be non-negative, or in other words, that is not both A and B should be negative. If both are negative, then the property fails. Is this property clear? This is a very important one. And if this is clear to you, initial mistake that I told you, this doubt, sir, I square. If some students ask this, I multiplied by I is equals to negative 1 into negative 1. Now, if there you write, sir, common under root minus 1 into minus 1. This equality, can you see that this step is wrong? Because you cannot do the common under root. From this step to this step, that equality is wrong. Okay. This was the property of I. Definition of a complex number. Any number of the form x plus iy, where x and y may be real, may be real numbers, or numbers involving I, or numbers involving I is called a complex number. So why this may be? Generally what we have read is complex number is x plus I, where x and y both are here. So consider this example. 2 plus 3i, yes, this is a complex number. Let's say 5 minus 2i, yes, this is a complex number. Under root 7 plus under root 11 times I, yes, this is a complex number. These are the very similar, means very easy examples. Now, if I would have said you, let's say x plus iy, no, x plus iy, so x I am giving minus 3 plus 2 minus 5y times I. So x I have given you a very simple one, minus 3, and y I have given you 2 minus 5y. Now, will you say that this is not a complex number? No, there is no need to say such thing. Even this whole thing is a complex number. Minus 3 plus in bracket 2 minus 5y times I. This is also a complex number. Okay. If you have read something about the real part and imaginary part of a complex number, yes, in that case, negative 3 is not the real part. 2 minus 5y is not the imaginary part. That imaginary, real and imaginary part I will explain. But this is a complex number. Don't get confused that so this x and y have to be, definitely they have to be real only. Okay. This is definitely a complex number. So complex numbers are generally this 0, and for that matter I can write 0 also, x plus iy. So why is 0? So because for 0 I can write 0 is equals to 0 plus I times 0 is also a complex number. So here can I write one remark? All real numbers are complex number. The reason is very simple. Take any real number of your choice. Let's say minus 7 upon 4. So you can definitely write minus 7 upon 4 as minus 7 upon 4 plus I times 0. So nothing new in it. All real numbers are complex numbers. So now the part of, now if this is the definition of complex number, what is the meaning of real part and imaginary part of a complex number? Real and imaginary part of a complex number. So let's say if a complex number z is represented in the form x plus iy, where x and y are purely real, कोई मिलावट नहीं, they are purely real, then real part of x, sorry, real part of z is equals to x, and imaginary part of z is equal to y. Take note that imaginary part is y, not I times y. Many students have this bad habit of telling the imaginary part is iy. No, iy is not the imaginary part. Imaginary part of a complex number is a real number. Okay, so for z is equals to x plus I times y. This condition is important. X and y are purely real. So according to this definition, if let's say Z1 is equals to 2 plus 3 times I, then real part of Z1 is equals to 2 and imaginary part of Z1 is equals to 3, not 3I. Okay, Z2 is equals to 5 minus 2I. So real part of Z2 is equals to 5, imaginary part of Z2 is equals to minus 2. Z3 is equals to 7, a real number. 7 is called as a purely 7, so Z3 is equals to 7. The real part is 7 and imaginary part of Z3 is equals to 0, and let's say Z4 is equals to minus I. Just that much, minus I. So real part, can I say? Real part of Z4. Minus I means what? 0, addition minus I, so real part is 0, and imaginary part of Z4 is equals to minus 1 it will be. Z4 equal to minus I. Don't say that imaginary part is minus. Imaginary part is minus 1. Clear up till now? No doubts? Okay. So from the last 2 points, I will just give a point for definition: purely real number and purely imaginary number. Purely real number and purely imaginary number. What do you think? What will be the definition of a purely real number? Sir, a purely real number will be a number whose imaginary part is 0. So example, 3, 5, 7, minus 18, and so on, etc. Purely imaginary number, a number whose real part is 0. So real part is 0. So what this number will look like? This number will look like, let's say, sir, 5 times I. 5 times I means 0 plus 5 times I. Okay. Minus 3I. Let's say 19 times I. Okay. Now where should I write this number 0 times I? Or let's say for that matter 0. Where should I write the number 0? You may say that a 0 fits in the definition of purely real number also, because its imaginary part is 0. 0 I can write as 0, addition 0 I, so the imaginary part is 0. So I may write 0 in the section of purely imaginary numbers also, because the real part is 0. 0 I can write it as 0 plus 0 I. So where should I write it? So 0 is included in the part of purely real numbers. That is just a convention. So no, means there is no reason for that thing. So you can say that purely imaginary numbers, all the numbers whose real part is 0 are called as purely imaginary numbers. The only exception for this definition is the number 0 itself. Okay. And now for this example, for the definition of complex that we saw, any number of the form maybe where x and y may be real. So negative 3 plus 2 minus 5y times I. I give x equal to this, y equal to this. This is definitely a complex number, but here you will not say real part equal to minus 3 and imaginary part equal to 2 minus 5y. Because that separation we can do only if x and y both are real numbers. 2 minus 5y is not a real number. So you cannot say that this is my x and this is my y. And representation of complex numbers. Complex numbers are represented, they are represented by ordered pairs of points on arrogant plane, or you may call it as complex plane, or you may call it as Gaussian. So if I tell you, let's say represent, let's say in school how you represent the coordinates of a point. If I tell you to, let's say z1 is equals to 2 plus 3i. So this is nothing on the Cartesian plane. This is will be just thus a real part is 2 and the imaginary part is 3. And you know how to plot the point on the xy axis. Here it's just here the terminology used is the complex plane, argand plane. Instead of xy plane, it is called as the argand plane. I call it as the complex plane. This horizontal x-axis. Horizontal x-axis is actually the real axis, where we represent the real part of the complex number. And this vertical y-axis is called the imaginary axis, where we represent the imaginary part of the complex number. Okay, so this point is actually one unit ahead, 2 unit to the right, 3 unit, 4 unit. So this one is actually what the pure real number one. This part is minus 1, minus 2, minus. What is this point? This point is, so real part will be 0 and imaginary part is 1. So real part 0 and imaginary part 1. What is that number? 0 plus 1 times I. This part is what? This point. So real part x coordinate is 0. X coordinate is 0 and the imaginary axis coordinate is positive 2. So 0 plus 2 times I. So this is will be 2i, the number 2i. This is 3i and so on. Here it will be minus I. This point is minus 2i and so on. So 2 addition 3i, z1, how it will look like? Z1 will be over here. This will be my z1. Represented by point P. Let's say this is my origin O, and this OP from O towards P. Okay. This arrow is also very important. This is now kind of, I'm also giving a slight introduction of vector also. You see, I've already studied vector in physics by now. This OP distance is called as the magnitude of Z1. Z1, you know how to plot. Okay, Z1, now this is just a plotting of the point 2, 3. And why I have written here the ordered pair. This also, I think it is clear because Z1 2 plus 3i and Z2 is equals to 3 plus 2i. I hope everybody is clear that so Z1 and Z2 are not the same complex numbers, because Z2 will be somewhere over here. My x coordinate should be 3 and my y coordinate should be 2. So my Z2 will be over here. So nothing new in it. This will be my Z2. Okay. So Z1 and Z2 are not equal. Therefore, we say that complex numbers are represented by the ordered pairs. Okay. And after this, now this is one thing which is not included in the board syllabus. Means it is given in your NCERT, but skipped from the boards. Since the syllabus is cut short. This OP, the angle that it makes with the positive x-axis. This slight introduction we have also seen in trigonometry. This part we have also seen in trigonometry. The angle that this ray makes with the positive x-axis, we take it sine and tan, sine, cos, tan, and all those things for defining the trigonometric ratios. Of vectors, I don't think there is needed for this theta. Now this OP is called as the argument of this complex number Z1. So you can just write it to be equal to theta 1. The ray OP, the direction also is important. The angle that it makes with the positive x-axis is called as the argument of complex number Z1. Okay. So here, just write argument of Z1 is equals to theta 1. For boards, we will not be discussing this part since this syllabus is cut off from your exam, the argument part. Okay. Z1 not equal to Z2. This is the representation of complex numbers. So to represent a complex numbers, you have to plot the real part on the real axis and the imaginary part on the imaginary axis. Now coming to this question, where was it? Negative 3 plus 2 minus 5y times r. Let's say consider I give you this question. Plot z is equals to negative 3 plus 2 minus 5y times I on the Argand plane. Okay. So in order to plot this point, what you will have to do? First, you will have to convert this z in the form of x plus iy. You will have your first target is z should be in the form of x addition I times y, where x and y both belongs to the set of real numbers. After that, I will be able to plot it. So here z will be equals to z is given to be equal to minus 3 plus 2 minus 5y times I. So this will be equal to negative 3 plus, not 2 minus 5y times I. I am directly using the distributive law. Actually, while using distributive law, I should tell, there is one point that I want to tell you. Okay. Yes, I will do a star mark over here. So 2 into I will be 2i, and minus 5 into this minus 5 minus 5 I square. So I square into will be negative 1. So can I just write it equal to plus 5? So this will be equals to negative 3 plus 5 is 2, and this 2i as it is. So I have converted z in the form of x plus iy, where x and y are purely real numbers. Now I can plot this graph. Now I can plot this point on the complex plane. 2 plus 2y. Nothing difficult now. This is my xy plane. 2 plus 2y will be over here. This will be my z. And this angle will be 45 degrees. 1, 2, 1, 2. Okay. Clear, everyone? principal argument of this complex number will be 45. Yes or no? Students, please reply yes or no.
Yes, sir.
Okay. Now here why I'm telling you to give a star mark, because as of now we don't know whether distributive law is true in complex numbers or not. We have not even seen multiplication of complex numbers, but I just wanted to tell you how to plot this point. Okay. Now this is the real part of complex number on the real axis. This is the vertical line is the imaginary part, and modulus. For complex number Z1, distance OP is called as the modulus of Z1, distance of that point from the origin, represented as the modulus of Z1 is equal to distance of OP. And so what is distance of OP? Can I say that my distance of OP is whatever is this horizontal x square, whatever is this horizontal distance square plus whatever is this vertical distance square, it's under root. Okay, so let me name this point as B. So OP is equals to, sir, OB square addition BP square, it's under root. Everybody will agree with me. So but what is OB? So OB is real part of Z. Real part of Z, its square. What is BP? BP is the imaginary part of Z, its square. Their addition and its under. Simple Pythagoras theorem, nothing more. Clear? Yes or no? So, two definitions. Modulus of Z.
Sir, one scroll down, sir.
Okay, just 1 second. Okay. For Z is equals to x plus iy, modulus of Z is equals to x square plus y square under root. This definition, be careful, I can write this definition because if and only if I'm damn sure that x and y are my real numbers only, means I have written this Z in the standard form. If I do this some horrible work like Z equal to -3 addition 2 minus 5y times I, if I do some work such as this, then you will not say that sir Z equal to x modulus will be equal to x square plus y square under root. Okay. So this in order to apply this definition, you should take note that for Z equal to x plus y, you should take note that x and y, they are purely real numbers. Means I have written Z in the standard form, and after that I have applied. So correct part, the more correct definition is the real part of Z, its square. So I'm not writing Z square over here. Means that this notation leads to confusion. So take Z square and then take the real part of the answer. There is slight confusion occurs. So that's why I'm taking real part of Z, its square. Imaginary part of Z square will be confusion. So I'm writing imaginary part of Z, its square. Addition. Pujita, I wrote this part only up. Do you still need me to scroll down?
No need, sir. Done, sir.
Okay. question. Find modulus and principal argument of z is equal to root 3 plus I. Write your answers in the chat box. Yes, that answer is correct. And what about the argument, Pujita? Dhananjay, can you tell me the argument? Argument, the definition, I hope you understood. So here z is equals to root 3 plus I. So you have already given this question very systematically that so here the x and iy, x plus iy, x and y both are my purely real numbers. So real part of z is equals to root 3 and the imaginary part of z is equals to 1. You don't have to do any manipulations, nothing. It was a question was given in the standard form only. So directly can I write some modulus of z? Modulus of z is equals to root 3 square plus 1 square under root of z will be equal to 2. No doubt up till here. And in order to find the argument, so on my real axis, I will go root 3 units over here. And on my imaginary axis, I will go 1 unit upwards. This is my 1 and this is my root 3. This will be my z. And I'm telling you to find the argument, what I'm actually asking.
Argument is pi by 6.
Yes, pi by 6. Very good. Okay. So 30, this is 1, this is 1, this is root 3. The trigonometry that we studied. The distance is 1, 3, this is 2. This is a 30, 60, 90 triangle. 1, 2, root 3. And 1, 2, root 3. So this will be 30 degree. 30 degree is pi by 6. Okay. If in case I would have given you, sir, root 3 minus I, let's say z2 is equal to root 3 minus I, if I would have given you. I would have told you to find the argument of this z2. So, sir, how the z2 would look like? So, z2 would look like this. Yes or no? This would have been my Z2 root 3 and the imaginary part is minus 1. So root 3 comma minus 1. So in that case, the argument, here the argument would have been what? Minus 30 degree. In the clockwise direction, we take minus 30 degree, or you can say that is equals to minus of pi by 6. Or in other words, you may have said that's the angle that this arm, the angle that it makes with positive x-axis. So with positive x-axis, it goes this much. So 2 pi minus pi by 6. 2 pi minus pi by 6. That would have also been correct. So 6 2s are 12 minus 1, 11 pi by 6. So for Z2, for Z1, the argument it is very easy, it is 30 degree. For Z2, either you say that the argument is minus 30 degree, or you say that sir, the argument is equal to 330 degree, which is 11 pi by 6, one and the same thing. Okay, this much only I'm going to teach the argument for boards, because argument is split out. I just wanted to give you an introduction for arguments. Okay, modulus and arguments clear?
Yes, sir, one more some.
Regarding arguments and modulus. Okay. Find modulus and argument of the following numbers. First, Z1 is equals to 3 plus 3i. Z2 is equals to minus 5 minus 5i, or Z3 is equals to minus 2 plus 2i, Z4 is equals to five minus 5i. Fifth, Z5 is equals to minus 10. Six, Z6 is equals to minus 8i. Can give answers in degree or radian. It's okay. Just write in the chat box when you are done. Means whatever question, and no need to write the answers. 1, 2, 3, 4, 5, 6. Yes, correct, Pujita. No need to write such a big statement. First answer is this much, this much. Just write 1, 2, 3, 4, whichever questions you are done. We will check together. first one modulus is 3 root 2 and argument is 45 degree. Pujita got it right. Dhananjay, I hope no doubts. Shall I explain all the six questions? Pujita, is it over?
Completing, sir. 1 minute, sir.
Okay. Pujita, shall I tell the answer?
Sir, 1, 2, 3 to answer mine.
Only 1, 2, 3, 3 only. Come on, this video is very slow. Modulus everywhere it will be just root 2 times. 5 square, 5 square, under root. So this is 5 root 2 square, 2 square, under root. So this is 2 root 2. Fourth one, 5 square, 5 square, addition 2 times 5 square, under root. So this is 5 root 2. Okay. And now regarding the argument, for the second question, negative 5y. This is magnitude is 5 and this downwards magnitude is 5. So this magnitude is 45 degree. Yes or no? For the second question. Correct?
Yes, sir.
So this was my angle. Direction is this. Okay. And I want that this ray OP with the angle that it makes with the positive x-axis. So anti-clockwise direction, 180 plus 45. 180 plus 45 is how much? 225 degree. Or that is also equals to in the clockwise direction. Clockwise direction, if you say that is equals to minus of 135 degree. Negative 2 plus 2y. So negative 2 plus 2y, it will be something like this. Negative 2 addition 2y. This will be the direction. Correct? Third one. So the answer, the argument will be this, which is equals to 135 degree. No need to go for negative value. Negative value. Sure. 5 minus 5y. 5 minus 5y. The real part is 5, imaginary part is negative 5. So this will be the complex number. This is 5. This is 5 downwards. So, correct? Yes or no, Pujita?
Yes, sir. Yes, sir.
So my argument will be this purple in the, but that is in the clockwise direction. So that is negative of 45 degree. If anti-clockwise, if you want to go, so anti-clockwise, it is from the positive x-axis up till here. So that is equals to.
The answer is 3 pi by 4, sir.
3 pi by
in radians.
3 pi by 4. No, 3 pi by 4 is 135 degree. See, pi by 4 is 45, no, Pujita?
Yes, sir.
So pi by 4 is 45. So 3 pi by 4, how that will look like? This is my pi by 4. This is my. See, pi by 4 का table जो रहता है, pi by, the table of pi by 4 is something like this. 1 times pi by 4, 2 times pi by 4, 3 times pi by 4, 4 times pi by 4 means actually pi. This is 5 times pi by 4. This is 6 times pi by 4. This is 7 times pi by 4, and this is 8 times pi by 4. So if you want to apply the table of pi by 4, think of it always in terms of a half of a quarter. Quarter, you know, quarter is the first one quadrant. One quadrant, that also you have to take into half. That also you divide into 2 pieces, and then apply that table. Pi by 4. Okay, Pujita, this is 1 times pi by 4.
Yes, sir.
2 times, 3 times. So how much that you have to do? For one quadrant, 2 jump of 2s. For second quadrant, again 2. So 2 plus 2, 4 plus 2, 6, and 1, 7. So that will be 7 pi by 4.
Sir.
7 pi by 4, or you may also call it equal to 270 for this 3 quadrants of 90 degree. 90 degrees 270, and 270 and 45. 270 and 45 is how much? 315. Now, negative 10. So negative 10 is how much? Negative 10 is nothing but minus 10 plus 0 times I. A purely real number. A purely real number magnitude will be 10 only. And so what will be the argument? Argument will be equal to 180 degree. Do you agree with me, Dhananjay and Pujita?
Yes,
Negative
sir.
10. This number will be plotted
Yes.
over here. So this will be my complex number set. And minus 8i. Minus 8i. So magnitude will be 8, and the argument, either you call it 270 degree with a plus, or you call it 90 degree with a minus. Negative 90 degree. Minus 8i, it will be on the negative y-axis. Negative imaginary axis.
Yes, sir.
Okay. Dhananjay, did you get all correct?
No, sir. In question number 5, I made.
Question number 5 you did wrong.
Yes, sir.
What answer did you write? Magnitude equal to negative 10.
Yes, sir.
Magnitude is always positive. Take under root. Magnitude is a distance kind of thing. Magnitude is x square plus y square under root. Under root is always positive. So that is negative 10 whole square, which is 100. It's under root, which is 10. It's kind of a distance. So that's all for now. Tomorrow we will study algebra of complex numbers, addition, subtraction, multiplication, division. Okay.